Hello everyone. So in this video we'll see what is achieving sublinear regret. Okay, achieving sublinear regret. So basically this ASR, that is achieving sublinear regret, I've made it in a short form. This means minimizing the difference between the cumulative reward obtained by an agent and the cumulative reward of an optimal strategy. Okay, in the previous video, remember we did this definition of regret. What happens here? To get a cumulative reward, we are and to get an actual reward we are following some strategy. Here also it is the same thing. Okay, but here what's happening, it means minimizing the difference between we are minimizing the difference. Okay, between what? Between the cumulative reward which is obtained by an agent and the cumulative reward of an optimal strategy. So to gain some reward we are following some strategy. That is what is achieving sublinear regret. Clear? Now it implies that as the agent gains more experience, its performance approaches that of an optimal strategy. What's happening here? For an agent, okay, or let's take a customer, if he wants to gain more experience, then his performance will increase, right? Its performance approaches that of an optimal strategy. So which path he has to follow, or which strategy he has to follow, he will know according to the experience and the performance. Okay, this is nothing but achieving sublinear regret. Now let's see, they are basically of 4 types. Now these 4 types I'll explain you with some examples so that you can remember it easily. Okay, so the first one is exploration and exploitation strategies. Exploitation strategies. This is nothing but balancing the exploration of new actions with the exploitation of known actions. Okay, balancing the exploration of new actions with the exploitation of known actions. Now I'll explain you with the example. Suppose you're going in a restaurant and you want to try some new dishes. That is what is exploration. Okay, you're ordering for some new dishes. But in the same way, you're going to the restaurant and you're occasionally ordering your favorite dish. I mean, you know that there are many other dishes also, but you have one favorite dish, that is biryani. Let's take an example. Okay, that is your favorite dish and it is occasionally you're ordering your favorite dish. That is what is exploitation. Exploration is you're trying new dishes at the restaurant. Exploitation is you're trying occasionally ordering your own favorite dish. Okay, so balancing your favorite dish and balancing your new dish. Okay, balancing the exploration of new actions with the exploitation of known actions. New actions and known actions. Clear? The next one is upper confidence bound, which is UCB, upper confidence bound. Okay, here what's happening, assigning confidence bound to each action's estimated value. What's happening, let's understand with the example. Now think of choosing a slot machine, any machine you're choosing. Okay, with that machine UCB considers average payout and higher payout. So for example, you're buying a book. Okay, in the small stationery you're getting that book for 10 rupees, and if you go to this to a mall and you buy the same book, then you will get it for 100 rupees, right? So you're considering the average payout to the higher payout. Okay, so for example, you're assigning the confidence bound to each action's estimated. So here you're understanding the estimated value and you're assigning some confidence bound to that each action. Clear? The next is Thompson sampling. Okay, Thompson sampling is nothing but you're taking a Bayesian approach by sampling from a distribution of possible models. Okay, taking a Bayesian approach by sampling from we'll understand this with the example again. So picture choosing. So imagine that you're choosing a path in a maze. Okay, instead of one taking route, you took a route which led to exit. So this is the entry. Okay, imagine you're taking this entry for this way is for entry and this way is for exit. But instead of choosing this route, you choose this route. This is an exit route and this is an entry route. But you don't know which is entry and exit, but you took this. So what's happening here? You're taking a Bayesian approach. So you're taking a route which is having an entry, which is a Bayesian approach, by sampling from a distribution of possible models. So if you're taking that route and then you get the sampling from a distribution of what are those? They are possible models. Okay. So the next one is optimism in the face of uncertainty. What's happening here? We're using optimistic initial values to encourage exploration. Example again, if you're estimating the value of different routes, so there are 4 different routes. Okay, we start with the high initial estimate for each route. Suppose if you're going to Pune, Goa and Bangalore and some other state, okay, you start to estimate what is the initial estimate, right? What is the, like, if you're going to Goa, it's around 10,000. Then if you're going to Bangalore, it's 20,000. If you're going to Chennai, it's 30,000, like that. You're estimating the value of different routes. Then we start with the initial, which is the highest one. Let's take 40 as a Bangalore, which is the highest. Then you adjust that with optimistic estimate. Matlab, you're trying to compare it with these prices, okay? Using optimistic initial values to encourage exploration. I told you what is exploration, right? This is exploration. You're trying new dishes at the restaurant. Matlab, you're trying something new. So that is what we are doing here. We are estimating the values of different routes, which start with the high initial estimate for each route and then adjust optimistic estimate. Okay, what is the definition? Using optimistic initial values to encourage exploration. Let's again, one time we'll just give a revision. Okay, achieving sublinear regret. ASR means minimizing the difference. You're minimizing, decreasing the difference between the cumulative reward obtained by an agent and the cumulative reward of an optimal strategy. Clear? 4 types. Thank you all.